We're all seeing it. The electric vehicle revolution is here and it's happening fast. But behind the scenes, away from the showrooms and highways, a massive safety challenge is brewing in a place most of us never think about, our global shipping ports. Today, we're going to pull back the curtain on this unseen world and figure out how exactly you safely manage mountains of EVs before they ever hit the water. Just to give you an idea of the scale we're dealing with, look at this number, 20 million. That's the projection for how many electric cars will be sold across the globe in 2025 alone. That's not a trickle, my friends. That is a tidal wave of new tech. And every single one of those cars has to move through a logistics chain that is racing to keep up. So here's our game plan. First, we'll talk about this electric wave and what it looks like at the ports. Then, we'll get into why an EV fire is a whole different animal. We'll look at the first line of defense, why it matters so much where you park these things, and finally, how you get ready for a worst-case scenario.
All right, Section 1. You know, for decades, these maritime ports have been experts at moving millions of gas-powered cars. It's a well-oiled machine. But this new flood of EVs, it's not just swapping out a gas tank for a battery. It's a fundamental change in the kind of risk they're dealing with, all concentrated in these huge lots right by the water.
It seems like a simple question, right? But the answer is really the core of this whole issue. You've got literally thousands of high-energy batteries packed together, just waiting. So where do they go? They end up right here, in these massive portside parking lots, sometimes for days or even weeks. But you gotta stop thinking of it as just a parking lot. It's really a giant temporary energy storage facility, and that concentration of lithium-ion batteries is what creates this really unique safety puzzle. And interestingly, how they're stored here is what decides if they're treated as a regular car or as regulated dangerous goods.
Okay, so let's get to the heart of it. A fire's a fire, right? Well, no, absolutely not. When it comes to electric vehicles, the lithium-ion batteries that power them burn in a way that is completely different and, frankly, way more stubborn than a regular fire. The term you really need to know is thermal runaway. This is the scary part. It's not like a piece of wood burning. This is a violent, self-sustaining chain reaction that happens inside the battery cell. Once it kicks off, it generates its own heat and its own oxygen, which causes it to spread to the next cell, and the next, like a bunch of dominoes falling over, all while spewing intense heat and some really nasty toxic gases. And this chart really lays it all out. A gasoline fire is pretty straightforward. It needs oxygen from the air to burn. So you hit it with foam, you smother it, fire's out. An EV battery fire, it's a whole different ballgame. It's self-oxidizing. It makes its own oxygen, so you can't smother it. The only thing you can do is just douse it with massive, and I mean massive, amounts of water to cool it down. And even then, it can just reignite hours or even days later. The risk is just incredibly high. So knowing how nasty these fires can be, how do the ports actually manage that risk? Well, it all starts with the first line of defense. Really strong, proactive steps to stop a fire from ever even getting started. It really boils down to this crucial three-step check. First, as soon as a vehicle arrives, it gets a thorough inspection. Any sign of damage, especially to the battery casing, any defect, any leakage, and it gets flagged immediately. Second, they limit the battery's state of charge. A battery that's only 20% full has way less energy to burn than one at 90%. It's just a lot more stable. And third, simple, clear labeling. A sticker on the windshield tells first responders exactly what they're walking into, and that can save precious time when it matters most. All right, now for the next layer of safety, and this one is a big one. Where you actually store these vehicles is a huge decision. The entire safety plan, and even how the vehicle is legally classified for shipping, changes completely depending on whether it's parked outside in the open or inside a building. And the reason why is pretty clear when you look at it side by side. Open yards are by far the preferred lower-risk choice. You've got natural wind to blow away any toxic gases. Heat can just dissipate into the air, and firefighters can get right to the vehicle. Indoors, it's the exact opposite. You're in a confined space that traps all that heat and gas, which just skyrockets the risk of the fire spreading to other cars. So for these open yards, this strategy is all about separation and surveillance. You leave wide gaps between rows of cars to act as fire breaks. You use thermal cameras to spot a battery that's getting too hot long before you'd ever see smoke. And this approach is absolutely essential for the big roll-on, roll-off vessels. You know, the ones that are basically giant floating parking garages. Because if an EV is undamaged and it's just driven onto one of these ships, under international maritime law, it's often not even classified as dangerous goods.
But if you have to store them indoors, the safety systems have to be way more advanced. We're talking sophisticated detectors for smoke, heat, and gas, powerful sprinkler systems designed for cooling, not just smothering, and massive fans for ventilation. Now, if you take an EV and you load it into a shipping container to be lifted onto a vessel, the rules change again. In that case, it's almost always classified as dangerous goods, and that comes with a whole other set of much stricter rules. This quote from the industry guidelines really says it all. This is the golden rule: no ifs, ands, or buts. If a vehicle is damaged in any way, if it's been in a flood, or if it's part of a battery recall, it is not allowed inside a building. Period. The risk is just too high. It has to be moved to an open area where it can be watched closely. And that brings us to our last section, the final layer in this safety net. Because after all the checks and all the planning, you still have to be ready for the worst. And that means having the right equipment and, maybe even more important, the right training.
Yeah, this is not a job for your standard fire hose. Fighting an EV fire takes some pretty specialized gear. We're talking about massive, heavy-duty fire blankets that can cover an entire car to try and contain the flames. Special piercing nozzles that can literally puncture a battery's steel casing to pump cooling water directly onto the cells. And even these mobile containment units that are basically big tubs you can submerge a whole burning car in. But look, all the high-tech gadgets in the world don't mean a thing if you don't have well-trained people. That's why constant, hands-on training for the port staff is an absolute must. They run drills, they coordinate with the local fire departments, so that if the worst does happen, everybody knows exactly what to do, and they're all on the same page. So the big takeaway here is that, yeah, this is a serious challenge, but it is absolutely a manageable one. Safely handling all these EVs at our ports is totally achievable. It just takes a really smart, multi-layered strategy. It's all about preventing what you can, detecting issues super early, and being totally prepared to respond if you have to. And that kind of leaves us with one final thought. We're still in the early days of this whole transition. As battery technology keeps evolving, we're hearing about solid-state batteries and all kinds of new chemistries. How is this safety playbook going to have to change with it? The only thing we know for sure is that staying vigilant and being ready to adapt is always going to be the name of the game. Thanks for tuning in.